Okay, hi. Yeah, okay, there we go. Now I'm recording. Hi, everybody.
Yeah,
Welcome to
sweet.
session number 2. There we go. There's my welcome. I did part of this decomposition.
Yeah,
Okay.
I just came in to like remind you.
Okay. Thank you. Thank you. I did forget. I did forget. So,
All right.
okay. So I'm going to take this bottom one, and I can just solve for c there. So it's going to be 6 minus. Oh, I'll do a different color. 6 minus 1 equals 4c, right? So 5 equals 4c, so c equals 5 over 4. So we solve for c, I can just put that in here, into these two equations. I mean, I can also just do this like with a matrix and solve it like that, but this is simple enough that I can do it just with this kind of algebra. So a plus b equals 0. 2a minus 4b plus 5 over 4 equals 0. I can take this equation, say b equals negative a, put that in here. 2a plus 4a equals negative 5 quarters. 6a equals negative 5 quarters. A equals, divide both sides by 6, negative 5 over 24. Okay, and then solve. So there's our C, A, put in B, so B equals 5 over 24. And there's our B. I should get the same color. Okay, we solved for A, B, and C. So now we can say that 1 over x minus 4 times x squared plus 2x, just remembering this, 2x plus 6 is equal to a over x minus 4. So negative 5 over 24 times x minus 4. So that's a over x minus 4. Then plus bx plus c is 5 over 24x plus c plus 5 over 4 over x squared plus 2x plus 6. Is this what I had the last time I did it too? No, different. Did not have this. I wonder which one's right. Different number. I mean, I screwed up at the end. I know that was wrong, so I guess that must be the wrong one. We'll see. So I can integrate that now instead, right? So the integral negative 5 over 24 times the integral of 1 over x minus 4 dx plus the integral of 5 over 24x plus 5 over 4 over x squared plus 2x plus 6 dx. So this is just negative 5 over 24 on absolute value x minus 4. Okay, and then this side, I can factor out a 5 over 4 from the top. So it'll be 5 over 4 times 1/6 x plus 1 over integral of 1/6 x plus 1 over x squared plus 2x plus 6 dx. And now I can't do another partial fraction. Can't decompose that on the bottom. This is similar to what I got stuck with up here. How do I do this? The derivative of this is 2x plus 2, which is not a multiple of this. Yeah, which is not a multiple of that, so it's not a U sub question. This... Any ideas? Anybody? I got nothing here. Yeah, this is the same thing I got stuck with before. I multiply by 6 on the top, I get x plus 6, but that's not helpful. Oh, no, I separate the fractions, I think. Separate the fractions. Yeah, someone's going to say
I think
something?
you might have missed something before.
You think so?
If you go up to where you are expanding A, B, and C,
Mm-hmm.
in that first line, is A supposed to go over to the plus 6 as well? And then I think...
Yep, it is. It is supposed to go to this plus 6, so that's 6a. Yeah, thank you for spotting that. So that's 6a, so that's 6a. So this is 6a, and this is all garbage. Okay, now we're back on track. Thank you. That definitely changed everything. Okay, so I will just do the linear algebra approach now, because it's not that easy to solve for. So this is also garbage. Okay, so now this is just a matrix. 1, 1, 0, 0, 0, 2, minus 4, 1, 0, 6, 0, minus 4, 1. And I will just put this into a online calculator because I don't want to do it. It's a 3x4. So 1, 1, 0, 0, 2, minus 4, 1, 0, 6, oh, minus 4, 1. Show steps. There we go. Okay, so this tells me, well, it tells me the same thing as I think what I did up here on this earlier time I did it. Well, let's just go for it. So it tells me A, but I think I know what to do now actually. A equals 1/30th, B equals negative 1/30th. Well, that makes sense because this is still up there. And then C equals negative 1/5. Okay, let me just have a sip of water quickly. Okay, so I can rewrite this fraction. This is also all garbage now. Fractions are different. You know what I can do? I can just do this. So I can rewrite this as, so it's a over x minus 4. So 1 over 30 x minus 4 plus bx plus c. So negative 1 over 30 x minus 1/5 over x squared plus 2x plus 6. Okay, that's good. So then I can now integrate that side. So the integral of this and this, well, I guess I can just say like that, right? Because that's the same thing. So it's going to be 1 over 30 ln absolute value x minus 4 plus the integral of negative 1 over 30 x minus 1/5 over x squared plus 2x plus 6. Okay, dx. So now I can separate the fraction. No, how do I do this? I was thinking separate the fraction, but no, that wouldn't work. Okay, if I multiply by 30, I'll have negative and then 15. Does that help at all? Make it a negative, that's positive now. That doesn't help because this is still 2x plus 2, which is x plus 1. No. Although if I... Okay, this might be weird. This might not actually help us at all, but if I change it to this, and then I rewrite it as 1 over 30, this might not work. I'm just thinking of something. So if I change it to that, integral of x plus 1 over x squared plus 2x plus 6 dx plus integral 1 over 30 times the integral of 14 over x squared plus 2x plus 6. Then this one I can do a u sub for. This one I can do a u sub for. So I can say u equals x squared plus 2x plus 6 du equals 2x plus 2 du. Du equals 2x plus 2 dx. Which is the same thing as 2x plus 1, right? So then if I just multiply by on the top here by 2, this would be over 60, and then that's a 2 there. Then this will turn into 1 over 30 ln absolute value x minus 4 minus 1 over 60 integral of 1 over u du. Plus 1 over plus 14 over 30 integral of 1 over x squared plus 2x plus 6 dx. Okay. So 1 over 30 ln absolute value x minus 4 minus 1 over 60 ln absolute value x squared plus 2x plus 6 plus 7 over 15 integral of 1 over x squared plus 2x plus 6. I don't know how to integrate that though, so we're not really that close, but yeah. Let's see. Let me see what the answer is in the book, and I'll see if that gets us any closer. Yeah, so it has a... Oh, I see. So I think what we're supposed to do now... is complete the square here on this one. Yeah, if I complete if I complete the square, I can use I have to find it. Where do I go here? Open folder. Let me find it. I can put it here. If I complete the square, I can use these formulas. Right? The integrals with using the inverse trig functions. So let me try that. Let's see if that works. And my OneNote is freaking out on me. Hello. Oh, it's writing, but it's not letting me erase. Hello? Okay, I will restart OneNote. Whoa. Okay, quick moment into the matrix, and then now is it gonna let me erase? Yes it is. And it'll let me move this? No, but oh, and now does it not want me to erase again? Yeah, for some reason it attempting to move this picture stops it from, okay, that's good, that's fine. So now if I complete the square here, x squared plus 2x plus 6, well I should say plus, well it will be plus, divide by 2, so take b, divide by 2 and square it, well that's just going to be 1. So now this will factor into x plus 1 I think. Yep, so x plus 1 squared, so subtract a 1, plus 5, yes, okay, this will work. So this 30 ln absolute value x minus 4 minus 1 over 60 ln absolute value x squared plus 2x plus 6 plus 7 over 15. Okay, integral of 1 over x plus 1 squared plus root 5 squared. Sorry, minus. Oh, no, it's plus. It's plus. Plus root 5 squared dx. Okay. After just one u substitution, u equals x plus 1. 1 over... Well, just copy and paste. Wow, okay. OneNote is not working for me today. There we go. Well, probably was just faster to just write it, but that's fine. 7 over 15 integral, sorry, and then du equals dx. It's just going to be 1 over u squared plus root 5 squared du, and this is exactly this down here. Yeah. Well, I just gotta pay attention properly. A little weird how they did it, but okay, so I'll put the root 5, just so I don't get confused, I'll put the root 5 squared there and the u there, but it's the same thing. So now this is exactly equal to that plus, that's absolute value of that plus 6, and absolute value at the end, not a 61. That looks like a 61. 7 over 15 times 1 over a, so 1 over root 5, tan inverse of u over root 5. And then just have the u is x plus 1 and plus c. Yep. That's good. And then just combine this fraction over here. It'll just be 7 over 15 root 5. I don't know if there's a simplification for that. 15 root 5. That doesn't sound like it can get simpler, but I guess I'll just plug it in just to be sure. Yeah, 15 root 5 is simple. So yeah, that makes sense. I don't know why there would be anything different. And that, I'm pretty sure, is the answer. If not, it's something very similar. So it's very close to the answer. No, that should be right, actually. You factor out a 60, is 1 over 60. A negative 1 over 60. No, just a 1 over 60. So if I factor out a 1 over 60, this is going to be 2 ln absolute value x minus 4. Just minus ln absolute value x squared plus 2x plus 6 plus this divided by 1 over 60. Which would be 7 over 15 root 5. 28 root 5. It's not quite the answer that's there. 28 root 5 over 5. Oh, wait, no, because they factor out a 60 instead. They don't factor, I mean, they factor out a 30 instead of a 60. Then how would that get? It's very close to the answer. Like the things are right. The constant multiples are wrong. So let's see if we can figure out. And they're not even wrong by a lot. It's just some of them have a weird factor in there. So what I have is 28 root 5 over 5. Over 5. Tan inverse x plus 1 over root 5 plus c. So this is correct. This is correct. This is the only thing that's wrong. This fraction right here, and I guess technically also this is 1 over 30 on the outside. Not just technically. That's so.
Can you scroll up?
Yeah. Yeah.
A little bit more.
Wow, OneNote is being weird today. It's not loading the. It'll load in a second. It just does a click maybe. Nope. Okay, how about I close OneNote? Turn it on again. I wonder why it's doing that. Never acts like that. Okay, where were you saying?
You scroll to a little more?
Mm-hmm.
When you multiply by 30, it's supposed to be... Wait, how'd you get 15?
15 here.
Yeah.
Well, I multiplied...
D6.
Oh! Yeah, what did I do? Yeah, that doesn't make sense. 30 divided by 5 is... 30 divided by 5 is 6? Yeah.
Yep.
So this should be a 5. This should be a 5, right? I think that should be a 5. That should be a 5. Where did the negative go here? Is that supposed to be negative? Yeah, where did the negative go? That should be negative here. Because it's negative 1 over 30 times that, so it's going to be that. Multiplied by 2 here, so multiply by 2 on the bottom. Yep, that should be negative. So this u sub is fine. This will be a minus 5. This will be a minus 1 over 6. Yeah. Then this still is right. This is still minus 1 over 6. I'm not going to quite still get the answer, but hopefully it'll be closer. Minus 1 over 6. Oh, no, sorry, minus, yeah, that's not right. Minus 1 over 6 times 1 over root 5. So minus 1 over 6 root 5. And then divide that to root 5. Yep. 2 root 5. And now we are, it's minus. We are right entirely, except this is supposed to be a 30. That's supposed to be a 30 on the bottom there, not a 60. Everything else is exactly correct. Now, how can that be? Is that okay? No, that doesn't seem like that's okay. That's not the same function. Is it okay because there's lawns? No, that also doesn't make sense. Everything else is identical except, well, that plus c can go at the outside. That shouldn't be in there, but yeah, plus c should be there. Huh. That should be a 30. That's our only thing that's not right here. Put it underline just to make sure it's not my writing. So what if I factored out a 30 instead? I wouldn't get the right coefficients here or here. So 1 over 60. No, it doesn't make sense. Let's try Wolfram Alpha. Let's see what it says. Wolfram Alpha. So what was the question? It was the integral of something over something. Something over something dx. So 2 over... Wait, did I multiply? No, I missed the 2. There, that's it. That's all it is. I missed the 2. Yeah. Hold on. Where'd the 2 go? 2 times this integral. I just didn't multiply by 2. So I just multiply by 2 at the end. Yep, there you go. That's it. I just missed the fact that it's 2 over. 2. It's the question gave us as 2 over So whatever this integral is, I just multiply by 2. So it's 1 over 30. And there we go. Now it's right. Okay, good. I'm happy that worked. Happy that worked out. Someone say something there? Or?
I said hi.
Oh, hi. How's it going? All I heard was robot for a second, so I didn't understand.
Oh, yeah, I just connected my headphones.
Yeah. I see. This was a long question. 207. We just did 207.
Oh, boy.
I've only this whole time I've been doing this one question. It was a long question, but good. We got the answer. That's the answer. It really got us to do like everything, all the difficult parts. Well, let's try 209. So 209 is the. I mean, does anybody have any questions about this one here? 207. I think we're good. 209 is the integral of x cubed plus 6x squared plus 3x plus 6 over x cubed plus 2x squared dx. Well, the degrees are the same, so I'm going to try to divide it. Right? So it's going to be x cubed plus 6x squared plus 3x plus 6 divided by x cubed plus 2x squared. Okay, and now I have to ask. This times what gives me that? Well, times 1 gives me that. 1 times that is x cubed. 1 times that is 2x squared. Subtract is going to be 0. 6 minus 2 is 4x squared, positive 4x squared, plus 3x plus 6. And I'm done. That's the remainder. So it's going to be the integral. So it's going to be x plus the integral of, I'll be more clear. So this is the integral of 1 plus 4x squared plus 3x plus 6 over x cubed plus 2x squared. Dx. So this came from there. This went there. This went there. And then this is just going to be now integral of 1 is x plus the integral of 4x squared plus 3x plus 6 over x cubed plus 2x squared. Okay. Well, now I can factor the bottom, so it's going to factor on x squared. So it's going to be x plus 2. Okay, that's good. Do I count this as 2 linear factors or 1 quadratic factor? I think I count it as... I think I can do either. I don't actually know. Can I do either there? I'll count it as a quadratic factor because it is quadratic. I mean, it has x to the power of 2.
Could count it as a linear and do like a
2
over x plus b over x squared.
Okay. Actually, that is simpler. Yeah. So I'll do that. Yeah. That's good. That's good. X. So I'll forget about the x plus for now. Just it's there. I mean, hopefully I don't forget it in the answer, but it's there. But our main focus is integrating this. So this is going to be 4x squared plus 3x plus 6 over x squared x plus 2 equals, so a over x plus b over x squared. So right now I'm treating it as a linear factor twice, right? Not a 1 quadratic factor. And then c over x plus 2. Multiply both sides by the bottom here. So it's going to be 4x squared plus 3x plus 6 equals ax x plus 2, that looks right, plus b x plus 2 plus c x squared. Yep, that's good. I guess I'll try the method where, like, so usually I never do anything except just expand and then put it into a matrix and RAF and solve for ABC. I'll try the thing where you choose value. So if I were to choose x equals -2 here, then it would be 4 times 4 is 16. I don't have to do that color. So I'm choosing this. This would be 16 minus 6 plus 6 equals 0, 0. And this would be 4c. So that cancels. It's 4c. So c equals 4. I see that it's useful. It's just, usually it's, I don't know, I'd rather just do it like with linear algebra, but it's fine. So choose x equals 0. It would be 6 equals b, 6 equals 2b. So b equals 3. And then for a, there's nothing I can choose for a to get that. Yeah, so what should I do? Just plug it in and then solve? Well, don't I just now have to do linear algebra anyways? Ah, that was a plus there. Well, I can put in the variables. So I can say 4x squared plus 3x plus 16 equals ax x plus 2 plus 3 x plus 2 plus, what was that, plus 4x squared. Oh, that cancels. 3x, so this is 3x plus 6. Oh, and that should be a 6. I don't know why I don't know why I wrote 16. I don't know why I wrote that. Yeah, 3x plus 6. That and that cancel. So 0 equals ax x plus 2. What am I doing? What? 0? So hold on, I'm confused. 0 equals ax squared plus, no, foil it. Yeah. What? Sorry, I'm confused all of a sudden. What am I doing? If I want to solve for a here, I can set x equal to some number. Let's just choose 1. So a times a equals 0. Yeah, a equals 0. Is that right? That doesn't make sense. Is a equal to 0? So it would be 0 x squared. And this would be 3. 3x. C is 4. No, that does actually work. Yeah, okay. A is 0. Okay. I don't know what's going on. Okay, anyway, so there you go. So it's 0 over x. So this term doesn't even count, actually. And it's going to be b over x squared, 3 over x squared. So the fraction, this one, 4x squared plus 3x plus 6. What'd you say? Sorry? Someone said something there.
Oh, no, don't worry. I'm still in the lek with Magenta. I just wanted to see what's happening.
Oh, okay, sounds good. This would be 0 over x plus 3 over x squared plus 4 over x plus 2. Yeah. So of course that doesn't matter, that term. Okay, now we can integrate this. So I can say here, this times the integral of this, not times the integral, but the integral of that, dx. So this over here is going to be 3, well, so x plus 3 times the integral of 1 over x squared plus 4 times the integral of 1 over x plus 2, forgot a dx there. So x plus 3 times, this is x to the minus 2 dx. So add 1 to the exponent, divide by the new exponent. So it's going to be x minus 1, negative, close bracket, plus 4 ln absolute value x plus 2, plus c. So this is x plus, x minus 3 over x plus 4 ln absolute value x plus 2 plus c. Negative 3 over 4x plus x. Yep, we're good. That's correct. Chose blue. There you go. Okay, this just confused me for some reason. The fact that a was 0, I wasn't expecting that, and then when this happened, I was just like, huh? But okay, that does actually make sense. Okay, so how are we about 209? Good. Okay, sounds good. So 211. Use the method of partial fractions to evaluate each of the following integrals. Not surprising. So this is going to be 3x plus 4 over x squared plus 4, 3 minus x. I like that they give it to us factored. So now this is an irreducible quadratic factor. If you imagine the graph, right, it's irreducible. And this is a linear factor. So what that means is that I can write 3x plus 4 over x squared plus 4, 3 minus x as, what can I write it as? I can write it as 3x plus 4, ax plus b over x squared plus 4 plus c over 3 minus x. Okay, that's good. Then multiply both sides at the bottom of here. So x plus 3x plus 4 equals ax plus b times 3 minus x plus c times x squared plus 4. I'll just do the linear algebra thing now because too many variables. So this is going to be 3ax minus ax squared plus 3b plus minus bx plus cx squared plus 4c. So 3x plus 4 equals negative a plus c x squared plus 3a minus b x plus 3b plus 4c. So negative a plus c equals 0. 3a minus b equals 3. 3b plus 4c equals 4. This first one is just saying that a equals c. This one over here I can just write as, well, not really any kind of nice way to write that actually. Although I can write this as 3c minus b equals 3. 3b plus 4c equals 4. I can rearrange this for b. So 3c minus 3 equals b. Put that in here. 3c minus 3 plus 4c equals 4. 9c minus 9 plus 4c equals 4. 13c equals 1. There we go. So a equals 1 because c equals a. Whoops. Come on. There we go. And b equals 3 minus 3 equals 0. Yeah. Sorry, equals 3 minus 3 equals b. So 0 equals b. So 1. So it's going to be ax. So it's going to be x over x squared plus 4 plus 1 over 3 minus x. So integral of x over x squared plus 4 plus 1 over 3 minus x dx. Oh, we're good. Never mind. I thought we were going to have trouble with this one, but that's just a u sub. So we can say this is the integral. I'll say u equal, well, first let's separate it. X over x squared plus 4 dx plus, and I'll just integrate this. So it's going to be ln absolute value 3 minus x plus c. Then here we can just say u equals x squared plus 4, du equals 2x dx. So this is going to be 1/2 the integral of 1 over u, yep, du plus ln absolute value 3 minus x plus c. I guess I don't need plus c yet, actually. So, don't need plus c. So this is going to be 1/2 ln absolute value u, but right away I'll put the u in. X squared plus 4 plus ln absolute value 3 minus x plus c, and that is the answer. Except this one's negative. The second one should be negative. Because what? Why should that be negative? No, maybe they just did something weird. No. Negative 3 minus. Why would that one be negative? Where did the sign come from? The sign came from the fact that c is positive. And c equals a, so there's no way that only one is positive and one is negative unless c doesn't equal a. 3ax minus ax squared, cx squared plus 4c, 3b minus bx. Okay, let's check Wolfram Alpha. Let's see. Integral of 3x plus 4 over, this has two factors, x squared plus 4. Yeah. 3 minus x. Yeah, there's a negative sign there. Nope, that's not what I meant to type. There's a negative sign there. Let's see what happened. Cancel, for the integrand, cancel common terms in the numerator and denominator? What common, what common? Just multiply by -1 there to have x minus 3. What? Huh? What? Use partial fractions. Oh, yeah, x. So where'd that minus come from? Yeah, where'd that minus come from? What? Here, show intermediate steps. These thetas for some reason, it's a little weird, but so, and they put it into a matrix. So yeah, they actually get a -1 out there. Did I do this wrong then? Then I did this wrong. Ah, come on, okay. Let's put it into a matrix. Using a lot of calculator here, but I don't want to just do it myself. Calculator. So this will be, so it's going to be, let me put in nice order. The equations we got was -a plus c equals 0, 3a minus b equals 3, 3b plus 4c equals 4. So this is a 4 by 3. And it's going to be -1, 0, 1, oh, sorry, 4 by 3, yeah. Sorry, 3 by 4. -1, 0, 1, 0, 3, -1, 0, 3, 0, 3, 4, 4. Calculate. So I got, yeah, nope, this is right. So then this is wrong. Okay, let's see. Let's go back to the start. Oh no, wait a second. I hate when it does this, come on. Wait. What I'm thinking is, okay, I can just multiply top and bottom by -1 here, right? And then this would become x minus 3. This would be ln absolute, so minus ln absolute value x minus 3. And that should be good. It's just that the answer, it's still 3 minus x.
Cutting out.
What'd you say?
You were cutting out. I couldn't hear what you were saying.
Oh, is that for everybody, or is that...
Yeah, you like freeze and then thing.
Oh, really?
I just thought it was only me, so I was like, it's probably nothing.
Oh, okay. I never, yeah, I'm usually lucky, and I usually don't get trouble. I don't know what...
You're fine now. It was just
Okay.
for a little bit.
Well, all I was saying is, it seems like I can... Only thing that's wrong is that there should be a negative sign at the end here, right? There should be a negative. This should be a negative right there. And so that means that somehow this should be a negative sign, right? This should be a negative thing there. And I can make it a negative thing, because right now it was 3 minus x. 3 minus, so this is what we had before, 3 minus x. I can multiply top and bottom by -1, and this will become x minus 3, x minus 3. It's just that, and it looks like that should be the answer. It's just that in the answer, it's still 3 minus x, and there's a negative sign here. So that wasn't how it's done. But my RRAF is right. Okay, 3x... Yeah, because in the answer, it's still 3 minus x. That's the thing that's tripping me up here. Unless that doesn't... No, it's off by a negative. It has to matter. Oh, wait a second. No, ln of -1 doesn't exist. Right? Ln of -1. No, ln of -1 does exist. No, ln of -1 doesn't. Wait, hold on. Yeah, because ln goes like that. Never mind. Because that, okay, then my idea was this, is that if this was meant to be no, that wouldn't change anything anyway, sorry. Still wouldn't change anything. Okay, let's go back to Wolfram Alpha. So they stay here, multiply top and bottom by -1. They do that here. But at what point, and that's fine, and they get this, but the answer still has a 3 minus x. I want to see how they got 3. No, they have x minus 3. Okay, then that does make sense. I thought that they had a 3 minus x. No, they have an x minus 3. Okay, so the textbook is just wrong. The textbook is just wrong. They just wrote it slightly wrong. And that's what's confusing. So let me explain what the confusing part was. Oh no, that's the question. The answer. So, okay. This is the same answer as what we have. This is the same answer as what we have, because you just do this thing, the thing that I said. Come on. Not letting me erase. Now it's letting me erase. Minus x minus 3 minus x minus 3. Okay, now we have this. We have the correct answer now. That's good. The thing that was confusing is that in the answer for in the textbook for number 111, I'm sure it's very small on the screen, but it says -ln 3 minus x. But that's not true. It's negative ln x minus 3, and I just verified that with Wolfram Alpha. That tells me it's negative ln 3 minus x. Sorry, x minus 3, which is what we have, which is the correct thing. And yes, when in Wolfram Alpha, they don't use ln for some reason. It's just log. Okay, there we go.
What are you doing?
We're doing 3.4, partial fraction decomposition, the homework.
Oh, okay.
Okay. 211. So 213. So any questions for 211? Okay, I think we're good.
It doesn't seem like it.
So 213. Oh my god. Okay, so we have to dig back into our advanced functions knowledge here. So 3x plus 4 over x cubed minus 2x minus 4 dx. And it says, hint, use rational root theorem. So essentially, we have to factor this bottom. So that's the hardest part of this question. Minus 2x minus 4. So factor this. Yeah. So to factor this, we have to do rational root theorem. And if I remember correctly, rational root theorem is you take the first digit, and it's been a few years since I've done this, but take the first digit, you take all the factors of the first one, which is just 1, over all the factors of 4. So the factors of 4 are 1, 2, 4. And
They're negatives.
Plus or minus of all these things. So plus or minus, so the only factor on the top is 1 over 1, plus minus 1 over 2, these are lists, plus minus 1 over 4. One of these, or 3 of them, I don't know, 1 to 3 of them, are roots to this quadratic, and we just have to test which one. So this is just plus or minus 1 at the front. Let's hope it's one of those. So 1, so let's just try positive 1. 1 minus 2 minus 4, that's not 0. Negative 1 plus...
No.
Negative 1, yeah, negative 1 plus 2 is 1, yeah, it's not 0. Okay, so it's not either of these. A half, I'll just do this all on my calculator now. Cubed.
Wasn't it 2? Why'd you put 1/2?
Because it's the factors of the top over the factors of the bottom.
Oh, okay.
Right?
I thought it was like brute force, just plus minus 2, plus or minus 4.
Well, so this is like even, it narrows it down a little bit more. It's the factors of the top. So the factors of the top are just 1, because it's just 1.
Oh, right.
Right? Over the factors of the bottom. 1, 2, and 4. This is just a vague memory in my head, so I would not be surprised if I do this wrong and none of these are the...
Well, the thing is, 2 works.
2 works, yes. So why are we not getting 2? Then you know what? It's probably Q over P. It's probably the factors of the last one over the first one. Let's look it up. Rational root theorem.
As far as I remember, it was like you put the roots of the last one, or the factors, sorry, of the last one, and then you just put them in and brute force it.
Let's see. It's not. He's gonna give me a nice thing. Factors of the constant, factors of the lead coefficient. Yeah. So this is like. So this is pretty much just like. That's true if the leading coefficient is 1, but if the leading coefficient isn't 1, then it could be rational things, right?
Yeah. So this one is already 1.
Well, yeah. So this one was fine. This was okay. And then so this is just going to be the next options are plus or minus, just the opposite of what I said, 1 over what I said, plus or minus 2, or plus or minus 4, right? Since the coefficient here is 1, because this is technically just over 1. But if that coefficient wasn't a 1 here, you'd have a lot more options, and a lot of them would be rational.
Yeah, that makes sense. Okay.
Right. So now we try all this. So 1 didn't work. 2 worked though. Positive 2. So 8. So 8.
So our factor is x minus 2.
Yeah. X minus 2 is the factor. So.
And here we go.
So I have to take x cubed minus 2x minus 4. So just to be clear here, x equals 2. worked. Like it makes this 0, right? So I'm going to have to divide this by x minus 2.
You could also synthetic division.
I never remember synthetic division. I probably didn't even learn it first. So, so I'm just going to do it like this. So what do I multiply the x by to get x cubed? Well, I multiply by x squared. So I multiply that, x cubed minus 2. Oh, sorry, I have to put a plus 0x squared here. Minus 2x minus 4. So minus 2x squared, subtract. So 0. 0 plus 2x squared is 2x squared. And minus 2x minus 4. What do I multiply x by to get 2x squared? Well, I multiply it by 2x. So this will be 2x squared minus 4x. Subtract 0. Negative 2x plus 4x is 2x minus 4. And what do I multiply x by to get 2x? Well, I multiply it by 2. So, okay. This will be irreducible, but that's okay. That doesn't actually matter. So this... Oh, no, that does matter. Okay, we'll see. We'll get there.
No, actually, we're doing partial fraction.
Yeah.
2x squared?
What'd you say?
Is it supposed to be plus 2x squared?
Where should it be plus 2x squared? Here?
Minus x, yeah.
Well, let's see. So it's
Oh yeah, it would be.
x squared.
No,
it would be negative because you're what do I multiply x by to get x cubed? X squared. So now multiply down again. So x cubed and multiply down here, that's negative 2x squared. That goes there.
Yeah, but you're supposed to subtract that.
Yeah, so then it's going to be 0 plus 2x. Plus 2x squared. So I get a positive 2x squared here.
Oh, right, okay.
Right? And there it is. So it ends up being positive down here. Yeah. And then, so 2x, and then that's just minus 4. So remainder 0. That's good. We did it right. Remainder 0. So now out of this is equal to the integral of x squared plus 2x plus 2. Oh, that doesn't matter because this is that's just a polynomial. That's fine. We can back to that. Oh, that's it. That's all it is. There you go.
No, we need the numerator.
But there's no. We divided it. This is what's left.
No, this was the theorem for the denominator.
Oh yeah. We didn't divide this, did we? We didn't divide that.
Yeah, I thought that
Okay. You're right. So this tells me that we have 3x plus 4. I was really excited there. I thought we could just do it. It was just going to be a polynomial. It's just going to be this plus 2x plus 2. Let's just see if that's reducible. So 2 squared minus 4 times 2. So 4 minus 8 is less than 0. So not reducible. That's the discriminant thing. So not reducible, so we can just go ahead and do it now. So I'm going to write 3x plus 4 over x minus 2 x squared plus 2x plus 2 equals
A over
a over x minus 2 plus bx plus c over x squared plus 2x plus 2. Multiply both sides by the denominator of the left side, so we have 3x plus 4 equals a x squared plus 2x plus 2 plus bx plus c, times x minus 2. 3x plus 4 equals ax squared plus 2ax plus 2a plus bx squared minus 2bx plus cx minus 2c. 3x plus 4 equals a plus bx squared plus 2a minus 2b plus cx plus 2a minus 2c. Let me make sure, absolutely sure I did that right.
Yeah, you're good.
It looks good? Okay, good. If someone else told me I'm good, then I'll take that. A plus b equals 0. 2a minus 2b plus c equals 3. And 2a minus 2c equals 4. Okay. So a equals negative b. So then I can just say this is negative 2b minus 2b plus c equals 3. And then I can just say this is should have really left it for a, but it's fine. Minus 2b minus 2c equals 4. Minus 4b plus c equals 3. So then minus c equals 3 plus 4b. Put that in here. Minus 2b minus 2 times 3 plus 4b equals 4. Minus 2b minus 6 minus 8b equals 4. Minus 10b equals 10. B equals negative 1. A equals 1. C equals 3 plus 3 minus 4. C equals negative 1. Okay. So 1, negative 1, negative 1. So that means I can take this. So it's going to be just positive 1. So 1 over x minus 2. So integral of 1 over x minus 2 plus, well, negative actually, minus x plus 1 over x squared plus 2x plus 2. Okay. Yeah, good. Dx is here. So now the derivative of this is, yes, good, we're good. Okay, good. This won't be very, very hard. So integrate this fraction is just going to be ln absolute value x minus 2 minus the integral of x plus 1 over x squared plus 2x plus 2 dx. We can actually do the u sub here. X squared plus 2x plus 2 du is going to be 2x plus 2 dx. In other words, du is going to be 2x plus 1 dx. Right? So I can just say ln absolute value x minus 2 minus 1/2 integral 1 over u du. So ln absolute value x minus 2 minus 1/2 ln absolute value x squared plus 2x plus 2 plus c. And let's check. Ln absolute value x minus 2 minus 1/2 ln absolute value x squared plus 2x plus 2 plus c. We're good.
Hey.
That's it. Okay. Okay, I think I might take a 10-minute break. Okay, and then I'll keep doing some more questions after. Okay, I just have a little break. Just, maybe eat something, drink some water. Everybody take a breather.
All right.
So I'll keep going in about 10 minutes. Okay. So I will go onto my AFK screen and I will be back at 7:35. Okay. See everybody in 10 minutes. Okay, I'm back, everybody. Get the screen going. Are you two here or muted or AFK?
Hi.
Hello.
Okay, good. Sounds good. 1 second. Okay, we're back. Hi. We also get a lovely message from my girlfriend here. Hi, everybody. Okay, we're good. Let's keep going with our problems. Number 215. 215 is next. Okay, so 215 is the integral of e to the x over e to the 2x. Am I still recording? Let's see. Yes, I wouldn't have stopped recording, so that makes sense. E to the 2x minus e to the x dx. Okay, so we can just say u equals e to the x, du equals e to the x dx. So this is going to be integral of 1 over x squared minus x dx, or u squared minus u du. Factor out the u here, and we now have a partial fractions question. Yes, a partial fractions question. So I can say 1 over u minus 1 equals a over u plus b over u minus 1. 1 equals a times u minus 1 plus bu. 1 equals au minus a plus bu. 1 equals a plus b u minus a. So a plus b equals 0, and negative a equals 1. A equals negative 1. Negative 1 plus b equals 0. B equals 1. Okay. So I can write this as 1 over u minus 1 minus 1 over u. So if I integrate this, that's going to be ln absolute value u minus 1 minus ln absolute value u plus c, du. Put the u back in. That was e to the x. So ln absolute value e to the x minus 1 minus ln absolute value e to the x plus c. Absolute value doesn't matter here. So this is just x. So ln e to the x minus 1 minus x plus c. And that's probably the answer. Yep, that's the answer. No, that's not the answer. It is the other way around. Always have trouble with this. It's 1 minus e to the x here. Why is it 1 minus e to the x? A was negative, B was positive. Let's try Wolfram Alpha and see if it's just another thing. It wasn't like similar to the last question, or it was just the answer in the book is just off by a negative. So this was the integral of something over something dx. So this was e to the x, e to the 2x minus e to the x. So 1 minus e is what they have here. So everything else is right. Let's see. I did that. Did that. E, is that what I wrote? Let's see. Oh boy. Is that what I wrote? Let's see. Integral of 1 minus u. Yep, that's what I wrote. 1 over, yeah. So negative ln u. Well, you don't have to do the substitution like that. You can just do like this. Yep, u minus 1, e to the x minus 1. An alternative form of the integral is, okay, in the answer here, it's e to the x minus 1. So is ln absolute value e to the x minus 1, is that equal to ln absolute value 1 minus e to the x? Let's try to figure it out. Well, this is off by a negative, of course, so it's ln absolute value e to the negative 1 times e to the x 1 minus e to the x, absolute value.
Is it minus e to the negative x? Might be so small.
No, because see, this is the alternate form. It doesn't have the x in there. You see the x over there? And that's not even what they have at the top here too, right? Here they have ln 1 minus e to the x minus x plus c. There's a minus x in there. See what I mean? So it appears that these are the same thing. I just don't see how exactly. So minus 1. So then this could be, if I'm doing my logarithm rules correctly, this would be ln of minus 1. Doesn't exist though. But this could be ln of minus 1 technically. Oh, with the absolute value? Oh, since it's in absolute values, if this is negative, if this 1 minus e to the x is less than 0, that means 1 is less than e. So e to the x is less than 1. Take the ln of both sides. Ln 1 equals x. Oh, sorry. If x is less than ln 1, that's negative. So then the absolute value would make, this would make it positive. But so, don't think that works. So, ln absolute value 1 minus e to the x. So since I'm taking what I'm thinking is that I'm allowed to do this, right? Multiply by negative 1 and flip it. And then since a logarithm rule is if it's a product inside here, wait, no. That's not right. If it's a sum, this isn't a logarithm rule I just did here, is it? That's just nothing. I'm just making up rules, aren't I? Let me make, I keep forgetting. Rules. I was about to spell rules wrong. I'm tired, I guess. So, yeah, no. Log of a product is the sum of the logs. Yeah, okay, that's fine. So since I'm taking the absolute value, this will be ln of 1 plus ln 1 minus e to the x. And since this is an indefinite integral, this is just your c. It's your arbit. It just adds to your c. So it doesn't matter. That isn't very convincing to me, because why are we allowed to... No, I guess. I'd like to see it graphically. Let's see. Let's see it. So if I say ln... Oh, I have to say log base e here. Log base e of... Don't need two sets of brackets. Log base e of e to the x minus 1. I know it's supposed to be an absolute value, so we'll do that in a second. And then log base e, no, not exponent e, log base e of 1 minus e to the x. No, something bad happened here. There. And then I'll just take the absolute value absolute value. So I guess they're the same thing. Yeah, I mean, they are the same graph, as you can see here, right? There's the red one. There's the blue one. There's the red one. Let's see why. If you were to take off the absolute value of the red one, then you lose the negative. Oh, because you can't do. So let's. What does e to the? Yeah, you know what? That's okay. This is enough for me, pretty much. I mean, not really enough for me to be really convinced, but just seeing that they're the same thing. See, they're the same graph. Okay, I can say okay now and just go with it. So yeah, they are the same thing. There you go. Not even off by a constant, actually. They are actually just the same thing. How do you get from one to the other? How is... So this is true. They are equal. I just can't figure out exactly how to get from one to the other without just saying off by a constant, right? Because off by a constant's okay when you're taking an antiderivative, an indefinite antiderivative. Well, whenever you're taking an antiderivative, period. So this is kind of still question mark. But okay, let's keep going. Next is 217. 217 is the integral of sine x over cos squared x plus cos x minus 6 dx. Pretty clearly, this is u equals cos x, du equals sine x dx. So this is integral of 1 over u squared plus u minus 6 du. 1 over that, like that. Factor the bottom. Two numbers that add to 1 and multiply to negative 6. So 2 and 3. Add to positive 1, so negative 2 and 3. So this is the integral of 1 over u minus 2, u plus 3. Okay. Du. Now, I can write 1 over u minus 2, u plus 3 as a over u minus, I'll skip a step here. A u plus 3 plus b u minus 2. And 1, make that equal to 1. So 1 equals au plus 3a plus bu minus 2b. 1 equals a plus b u plus 3a minus 2b. A plus b equals 0. 3a minus 2b equals 1. A equals negative b. Negative 3b minus 2b equals 1. Negative 5b equals 1. B equals negative 1/5. A equals 1/5. Okay. So I can integrate 1 over. So this was, you know what? I should have done this differently. The integral of a over u minus 2 plus b over u plus 3. Getting a phone call, but I won't answer this second. It's okay. So du. So that's going to be 1/5. So 1 over 5 u minus 2 plus, minus 1 over 5 u plus 3 du. So this is just going to be 1/5 ln absolute value u minus 2 minus 1/5 ln absolute value u plus 3 plus c, and u was cos x. So 1/5 ln absolute value cos x minus 2 minus 1/5 ln absolute value cos x plus 3 plus c. Yep, and wow, really not getting any luck, are we, today? Let's see. So the answer, okay, so first of all, I know I can do this. 1/5 ln absolute value cos x minus 2 minus ln absolute value cos x plus 3 plus c at the end here. And then I can do 1/5 ln absolute value, and this would be cos x minus 2 over cos x plus 3, absolute value of that, right? The thing is that this is flipped. So that's the power of -1, so that should be negative in the front there. But it's not negative. It is not, I don't know. Okay, give me 1 second, guys. Sorry, someone's just calling me. Okay, so 1/5 ln absolute, yeah, so we're off by a negative there. I'll check it before I do Wolfram Alpha. Let's see. And now OneNote is not working. Okay, let's go back to this time. U equals cos x. So that's going to be du equals sine x dx. Nah, du equals negative sine x dx. Okay. The first move, we made a mistake. So I made a mistake. So there we go. That's the problem. Negative, 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 and negative. That should be multiplied by a negative. That should be multiplied by a negative. That should be multiplied by a negative. Okay, we're good. that's all the mistake was. And then since this is negative here in the front, since the answer is this fraction flipped, it's just like with the log rule. You can just move the negative up. So it's this to the power of -1, which is just the flipped fraction, right? So then you get the answer in the book. Okay, so 219. Let's see, 219. 219 is the integral of 1 over e to the t minus e to the negative t squared dt. So e to the t minus e to the negative t squared dt. Okay. I can square it. I can actually do the FOIL, I guess. I guess I will. So integral of 1 over e to the t squared minus 2 minus 2, actually, that's it, plus e to the, well, this times this, so that's going to be, you're multiplying them, so you have to add the exponent, so minus 2t. I guess this should be 2t here, 2t. E to the 2t, yeah, minus 2t. Yep, that makes sense to me. dt. Okay, bracket doesn't do anything. I don't know why I wrote that. Why is this any better than what we had before? It's not really. E to the t. Okay, let me write our original integral here. Integral of 1 over e to the t minus e to the negative t squared dt. That's the original integral. I foiled it here. Did I foil it correctly? Yes, I did. It's 2, that times that is e to the 0, which is 1. So that happens twice, okay, and then positive e to the negative 2t. Should I try to get them all over the same denominator? Because this is really, wow, OneNote is screwing up on me today. Many, many times it's not letting me erase. There we go. 1 over e to the 2t. so I could get them all on the same denominator? Okay, guys, sorry. Give me 1 second. I just gotta answer the phone quickly. I'll be just a minute. Okay. Here, I'll go on AFK one more time. Oh no, that's the wrong one. Okay, give me just like literally 1 second. I'll be back in a second. Okay, I'm back. Hello. So are we still going here? That's all working? Okay. Everybody can see me, right? The 3 people that are here. Hopefully. So okay, if I want to put them all in the same denominator, then I multiply top and bottom here by e to the 2t. That might work, actually. 1 over e to the e to the 2t over e to the 2t times e to the 2t over 1 minus 2e to the 2t over e to the 2t plus 1 over e to the 2t. So then this is just going to be e to the 4t. So this is going to be 1 over e to the 4t minus e to the minus 2e to the 2t plus 1 over e to the 2t. So this will be e to the 2t over e to the 4t minus 2e to the 2t plus 1. Now can I say u equals, so I can put this in the integral again. Integral of e to the 2t over e to the 4t minus 2e to the 2t plus 1 dt. And now can I say u equals e to the 2t du equals e to the 2t 2e to the 2t dt. Yep. So I can say 1/2 integral 1 over u squared u squared minus 2u plus 1 du. Okay. Factor this is going to be x minus 1 or u minus 1. Pretty sure. Two numbers, -1 times 1. Yep. 1/2 integral 1 over u minus 1 squared du. I don't need to do partial fraction decomposition, do I? No, I don't need to do partial fraction. I can just say alpha equals u minus 1, d alpha equals du. So I can say 1/2 integral 1 over alpha d alpha. I know alpha is a weird variable choice there, but whatever. Sorry, alpha squared. D alpha, yep. So 1/2, no. Oh, yeah, never mind. This is alpha to the power -2. So add 1 to the exponent, alpha to the -1, divide by the new exponent, negative. And plus c, sub in alpha is u minus 1, so -1/2. So it's going to be -1 over 2 u minus 1 plus c, and then u was e to the 2t. So -1 over 2 e to the 2t minus 1 plus c. And so this is -1 over 2 e to the 2t minus 2 plus c. and just apply the negative to the bottom. They really do extra weird steps for some reason, but they just apply the negative to the bottom. So it's 1 over 2 minus 2e to the 2t plus c. That's the final answer. We're good. Okay, that worked out. So I FOILed it, got it as like a polynomial, and then I just subbed in a u in there, so it actually became a polynomial. Sorry, I made them all over the same denominator, and then I did that. And then the reason I couldn't do a u sub to begin with is because the derivative wasn't in the top, but now after all that, the derivative, come on, there you go. One note, again, not working. Come on. I think if you give it a second, it'll do it. No. Wait, now? Okay, just enter the matrix for a second, and then we're out. Get a little break while OneNote launches. Don't know why my computer's being weird. Is it okay? Let's open Task Manager and see if it's okay. Well, it's CPU 100, but now it's better. Okay, no, it's not CPU 100. No, we're okay. OBS uses a lot of power, but that's about it. Okay, I don't know. That could be it, honestly. We'll see. Maybe my video settings are weird. So then, yeah, after I did the same denominator thing, I can do the u sub because there is the derivative in the top. Or a scalar multiple of the derivative. So that was 219. That was a good question. 221 is going to be the integral of 1 over 1 plus root x plus 1 dx. Yep. So here we will do, u equals x plus 1. du equals dx. So integral 1 over u plus 1 du. And this is just ln absolute value u plus 1 plus c ln absolute value x plus 2. That doesn't make sense. What did I do there? What? Is that the answer? No, that is not the answer. What mistake did I make there? Oh, because it's square root of u. There you go. Yes, it's square root of u, not just u. Okay. Square root of u plus 1. Okay. Square root of u plus 1. That is a square there. Is this not, it doesn't seem like I'm allowed to do this, but can't I do 4th root squared? And now it would just be, no, it wouldn't be that. Because I could think we could use tan, but no, we can't do that. So what am I thinking? I need to, this is partial fraction decomposition, so I need to somehow use partial fraction decomposition. If I multiply top and bottom by, no, it doesn't help us. If I said u equals 1 plus root x plus 1, the derivative of this would be the derivative of this, so it would be 1/2 over, well, this isn't looking too good, the derivative of the inside. Oh no, 1/2 over, I mean, sorry, x plus 2x plus 1 times the derivative of the inside, which is just 1 dx. We don't have that here, so that's not helpful. We don't have linear factors on the bottom. We don't have any kind of factors on the bottom. This seems like a better form, but I don't really know what to do after that. If I say t equals root u plus 1. dt is going to have to be the derivative of this, which is 1/2 root 1/2 root u times the derivative of u which is just 1, so that's fine. 1/2 root u. That's not on the numerator, so unless I factored out a root u, wouldn't do anything. That wouldn't help us. Unless I was thinking I'd factor out a root u from this, because then it'd be root u times 1 plus 1/root u. And then I could just say 2. Let's try. Let's see. That might work, actually. Let's see. I will factor out a root u. So root u times, in fact, I'll do it on the other side. So it'll be 1 plus 1/root u du. Then I will say, so 2 times the integral of, oh, that doesn't help us because that's there. Never mind. 1 plus,
Maybe try multiplying top and bottom by root u minus 1.
okay, yeah, I like that. Let's see. I'll erase this. These, well, I guess, yeah, so I will stick with this u sub. So u equals x plus 1, du equals dx. So I will yeah, that makes sense. I'll multiply top and bottom by root u minus 1 du integral. So this is just going to be root u minus 1 over u plus 1, u plus 1. Okay. Du. Okay. I can separate this now. Integral of root u over u plus 1 minus integral of 1/u plus 1 du on both of these. That one we don't know. This one will be ln absolute value u plus 1 and plus the integral of root u over u plus 1 du. What was u again? X plus 2. Minus 2. Okay. Minus 2. Looking at the, I keep forgetting the question, 221. Looking at the answer, try to get some hints. No, the ln doesn't have that. The ln has the full 1 plus, so in the answer, there's a ln of 1 plus root 1 plus x, which tells me that at some point they do a u sub for it. I think. I think they do a u sub for it. What's the derivative of that? 2 times that root 1 plus x over 1 That's not a linear factor, no. Okay, I say Wolfram Alpha now. Let's see what Wolfram Alpha says. Integral of this over this. So this is 1 over 1 plus square root of x plus 1 dx. So, of course, that's the same answer that we have. Root 2 root x plus 1 minus 2. Oh, that's right. Let's see. So we did that. We get that. Okay, what did we do after this? S equals root u, didn't I? I mean, sorry, the next integrate again. Root u. Okay, I'll go from there. I think we got stuck though, didn't we? So it's from here. So from here, integral of 1 over root u plus 1 du. So we'll say t equals root u, dt equals 1/2 root u. That's it, 1 over 2 root u. But that's not on the, sorry, du. But that's not on the, how do I make that? Yeah, how do I do that substitution? So that's what I said, right? 1/2 root u. Oops. 1/2 root u. And how root u 2 times multiply top and bottom by root u. Oh. Yeah, and then it just works. And then you can just say 1 over t, or sorry, t over t plus 1 dt. Just multiply top and bottom by root u. I didn't think of that. That's kind of weird. I don't know. That makes sense, I guess. I just feel like, I don't know. Yeah, that makes sense. That just fully makes sense. I don't really know why I didn't even think of that. It just feels for some reason like we weren't ever doing that. But why wouldn't you? You just multiply by 1. Because now you have the 1 over root u. And the 2 comes from here. Okay. Okay. And then this is just no partial. Hold on. What do I do here? T over t plus 1, 2 integral t. U equals t. Could I just say u equals t plus 1? Or another u sub? Alpha equals. It's a lot of u subs, but t plus 1. D alpha equals dt. And so then t equals alpha minus 1. So this would be 2 integral alpha minus 1 over alpha d alpha. So 2 times the integral of alpha over alpha d alpha minus 2 times the integral of 1 over alpha d alpha. So this is, oh sorry, no, that can't be right. No, that is right. 2 alpha minus 2 ln absolute value alpha, which is 2 t plus 1 plus 1 minus 2 ln absolute value t plus 1. T was, we're going way back, root u. 2 root u plus 1 minus 2 ln absolute value root u plus 1 and x plus 1. So 2 root x plus 1 minus 2 ln absolute value root x plus 1 plus 1. Is there 2 in both of them? Yeah, there is. What did I say the answer was? Oops. What did we say the answer was here? 2. Well, that's fine. That is right. Minus 2 ln. Yep, that's right. That's exactly right. The reason this is still right, even though it's technically off by a constant, is because it's okay when the antiderivative is off by a constant, because you have 2 root x plus 1 plus 2 minus 2 ln absolute value root x plus 1 plus c. Well, you can just move that 2, this 2 that's there, all the way over there. So it's just plus 2 plus c, and there, that's just your c, 2 plus c. So 2 root x plus 1 minus 2 ln absolute value x plus 1 plus c. So there's that. A lot of good questions here, honestly. A lot of very complicated ones. So we did like 3 u-subs. 1, 2, 3 u-subs. And we got to the answer. Which I guess also makes sense because it's function inside of a function inside of a function. So, sure, 3 u-subs would have to do that. Okay, there's that question. I'll probably do just a couple more, and then that'll be it for today. This was number, what was it? Number 221. Okay, let's do 223. 223 is the integral of cos x over sine x 1 minus sine x dx. Jumping ahead a little bit there. Sine x, u equals sine x, du equals cos x dx. So integral of 1 over u, 1 minus u du. So I can just partial fraction this. The last couple questions didn't have partial fractions. Just realized. A little strange. All these questions didn't have partial fractions. Yeah, the last 2 questions didn't have partial fractions. This one did. Okay, well, it's good integration problems though. So 1 over, I'll skip ahead a little bit. 1 equals a 1 minus u plus bu. 1 equals a minus au plus bu. So 1 equals a plus b, minus a plus bu plus a. Minus a plus b equals 0, which tells me b equals a, and a equals 1, so b equals 1. Oh, which I didn't have to actually do, so that's okay. So the integral of 1 over u plus 1 over 1 minus u du, which is just going to be ln absolute value, well, that's the negative sign. Well, let's get to the answer anyways. Ln absolute value, u plus ln absolute value 1 minus u plus c. U was sine x. So ln absolute value sine x plus ln absolute value 1 minus sine x plus c. And I lost a negative because this should be a negative sign. Let's see where. Unless, again, this is a problem with just the textbook being weird. I think I have a feeling this is, again, one of those things with the textbook being weird. So this is the integral of, I think that we actually might be right on this one. This was, sine x, no, sorry, 223 we're doing? Yeah. Cos x over, this is 2 things. The first thing is sine x. 1 minus sine x. So ln absolute value sine x minus ln, yeah, but again, is that not a big deal? I have a feeling, oh, it's not giving me the solutions. Screwing up. Wolfram Alpha, what's going on? Yeah, it's just not giving it to me. Plain text. Print. Will it give me the whole thing? No, won't give me the whole thing. Well, we can't see how they do it. Some reason Wolfram Alpha just decides to stop about here. But again, I think that's the same reason as before. I think that's fine. I think that's okay to be off by that negative. I have to check on Desmos. I don't know. It doesn't seem right. But let's just check. Let's just do it like, is log base e of absolute value of 1 minus f of x equal to, oh, I have to actually make an f of x, hold on. F of x equals 1. Oh, no, it can't be 1, sorry. 2. Oh, actually, so let's just make it x there. And then is that equal to log base e of the absolute value of f of x minus 1? And is that true for any function? Looks like it is. E to the x we know is right. Yeah, looks like it's right. I'd like to see some sort of proof of that. Maybe it's too difficult for us to understand, but what's another function? I don't know. What if I said log base x? Log base 10 of x. Yeah, that's fine. So it looks like it's always true. How do you do it? Is it because you're taking the absolute value? I guess it's because you're taking the absolute value. Yeah, it's because you're taking the absolute value. So this is off just by multiplying by -1. That's how they're off. But since you're taking the absolute value, they're just off by multiplying by 1, which is the same thing. So they're not off at all. That seems to make sense for me. I just want to, that absolute value thing is confusing me a little bit, but not confusing me, but it's giving me some doubt if we're right or not. So anyways, looks right. That's good. Sorry, I spent too much time on each question going over the answer. I mean, I want to make sure I'm right though. So 225 is a, well, it's 225 is a definite integral. Okay, I guess I'll do the definite integral because I don't know the answer. I might just, well, no, I don't want to skip it. It looks like a good integral. So let's try it. This is going to be the 1 over x squared root 4 minus x squared dx. Is that I write that right? 225. Is that what I'm doing next? I just did 223, 225. 1 over x squared 4 minus x squared. Okay. So, can I say u equals 4 minus x squared, du equals negative 2x? I can't really say that, but negative, sorry, dx. Is there any way I can make that work? If I say here that x squared is equal to no, that's not going to work. Oh, I guess I have nothing else to try, so x squared is equal to 4 minus u. So x is equal to the square root of 4 minus u. So I can multiply top and bottom here by x. And I get negative, no, this isn't going anywhere, I know, but 4 minus u over, oh no, sorry, there's no x on the top anymore. It's just 1 over 4 minus u 4 minus u square root of u. du. That's not any simpler at all. So, yeah, that's not any simpler. Nope, that's nothing. Okay, let's write the original integral here again. Integral of 1 over x squared square root 4 minus x squared dx. Oh, I can it's squared, so I can. No, never mind. For a second, I thought I could put it in. I could say x to the 4 square rooted, but that's not really anything. Is this just a one of these from earlier? It's kind of similar to 1. It isn't 1, but it's kind of similar to 1. Didn't put on? Hello? Oh no, it's freaking out on me a little bit. So let's see. No, didn't want to put it. Let's try again. No. Wow, OneNote is really being weird today. This thing. This thing. That is kind of what I was looking at. And it is kind of that. It's just that it's u squared there. It's not that at all.
Change oh wait, never mind.
1 over x squared 4 minus x squared. There, I think there's some u sub we can do. I think there's some u sub we can do. Or is there a trig sub we can do? I just realized, why don't we can do that too. Yeah, why can't we use trig subs? I think we can do that. Maybe that's what this needs. Wrong notes. I do still need my notes for trig subs, so I don't get it wrong. So we have this would be a sine substitution. Let's give it a try. Who knows? Let's see. X equals 2 sine theta. Dx equals 2 cos theta d theta. So this would be the integral of 4 sine squared theta over 4 times 1 minus sine squared theta over 2 cos theta d theta. This would be the integral of 2 cos theta over 4 sine squared theta. That'll be this will be I'll factor out the 2 goes out here, and this will be the square root of cos squared, which is just going to be cos theta. So that and that cancel. So it'll be d theta. So it'll be the integral of 1 over 4. So 1 over 4 sine squared theta d theta Okay. Looks nicer. How do I deal with this now? Oh, it's because this is 1/4 integral cosecant squared theta d theta. How do you integrate this? 1 over... the derivative of cotan is negative cosecant, so this will be negative 1/4 cotan theta. The derivative, yeah. Yep, that looks right. So then I will sub in negative 1/4 plus c, but I'll forget the plus c. Well, no, I'll put plus c. Theta is the sine inverse of x over 2, right, from here. Sine inverse of x over 2. And then negative 1/4 cotan. Oh, well, I have to do this. So sine theta equals opposite over hypotenuse. So it's going to be x over 2, like that. That's theta. This length over here is going to be 2 squared minus x squared square rooted. Yep, that sounds right. And then cotan is 1 over tan. Tan is opposite over adjacent, so adjacent over opposite is what we need. Adjacent over opposite is that, so it's going to be 1/4 2 root 4 minus x squared. So again, plus c. Plus c here. So this is going to be minus root 4 minus x squared over 8 plus c. This will be a definite integral, so I'll just say c equals 0. So I'll just do that. And now I need to, so this was definite. This was the answer. The question was a definite integral. So I integrated it. I mean, there's that. I don't know. Let's see if it's right. So then if I if I evaluate it from the bounds were 1 to 2. So at 2, it's going to be negative square root 2 squared is 4. 4 minus 4 is 0, so it's nothing. So we're just evaluating negative at 1, so it's going to be positive. Square root of 4 minus 1 over 8. Square root of 3 over 8. And we're so close. It's square root of 3 over 4. So that's a good sign, though. That's a good sign. Let's see. We're just off by 2. Well, we're off by a half, actually. But well, let's go through it, I guess. Let's go right from the beginning. So ignore this. This is all nothing. This is nothing. This is nothing. Okay. So here we say x equals 2 sine theta. X equals 2 sine theta. That makes sense. Just checking. dx equals 2 cos theta d theta. So this is 2 cos theta d theta over 4 sine squared theta, because it's squared. 2 squared is 4, times the square root of 4 minus 4 sine squared theta. 4 minus 4 sine squared theta. Factor out the 4. 1 minus sine squared theta. That's cos squared theta. Square root of 4 is 2. Cos theta. Those cancel. 1 over 4 sine squared theta. 1 over 4 times the integral of 1 over sine squared theta. D theta, 1 over 4 times cosecant squared theta. The derivative of cotan is negative cosecant, so the derivative of negative cotan is cosecant squared. I meant squared before. So it's negative 1/4 cotan theta plus c, choosing c equals 0. negative 1/4 cotan of sine inverse of x over 2. Thinking, am I missing something there? No, I don't think I'm missing something there. X over a, yep, no, we're good. A cos theta, right? Yeah. So then sine equals...
I think I see where...
Yeah?
So under like negative quarter cotan arc sine of x over 2, underneath, when you substitute it back for cotan, you put adjacent over hypotenuse. Shouldn't it be?
Yes. Yes, it should be.
Adjacent over opposite?
Yes. TOA, yes. Tan is opposite over adjacent, so this should be adjacent over opposite. So it should be that over x, but OneNote doesn't want me to erase today. Okay, give it a second. Come on. It lets me write. Doesn't let me erase. Can I click the eraser? No, that doesn't work either. And now I have both the eraser and the pen tool selected. Okay. That is the answer, what you said there. That was the problem. Okay, we're back here now. Back in this dimension. Okay. So now I can go here. Oh, I didn't even save the stuff I just did, so really it was screwing up. So here, this will be a x. I'll put x there. X. Evaluate from 2, so it's still 0 there, and this is just now over... Oh, where'd the 1/4 go? It's still a quarter. The quarter didn't go anywhere. So this is a 4 at the bottom. This is 4x. Yeah. So at 2, it's still 0, and at 1, it's still negative this, so positive root 3 over 4. And there's our answer. Okay, great. Perfect. That's the answer for that one. What question was that just now? That was 225. Okay, I think I'll do one more, and that'll be everything for today. And maybe tomorrow we'll finish them up, because there's still quite a few more in this section, and they're all pretty good integration questions, I think. I like them. So 225. So let's do 227. That'll be our last one for today. So 227 is, I was looking at the answer instead of the question. 227 is the integral of 1 over 1 plus e to the x dx. Okay. So 1 plus e to the x dx. I'm thinking. Multiply top and bottom by e to the x. Say u equals e to the x. Du equals e to the x dx. Integral 1 over u times 1 plus u du. That worked. Didn't think that would work that smoothly, but yes, that worked. Multiply top and bottom by e to the x, because that gets the derivative in the top, and then now we just have this. We did this partial fraction decomposition before with a minus sign, so of course we don't get to do it now. Okay, so 1 over, I'll skip a few steps here. So 1 equals a 1 plus u plus bu. 1 equals a plus au plus bu. 1 equals a plus bu plus a. A plus b equals 0. A equals 1. 1 plus b equals 0, b equals negative 1. So this is the integral of 1 over u plus minus 1 over 1 plus u du. So this is ln absolute value u minus ln absolute value 1 plus u. And we can now put u in. U was e to the x, so ln absolute value e to the x minus ln absolute value 1 plus e to the x. And this will be simplified to ln absolute value e to the x over 1 plus e to the x. Oh, actually, never mind. It won't be. It won't be that because and that's technically right too, I think. But this is x, so it's x minus ln absolute value 1 plus e to the x plus c. Forgot a plus c on all these. Okay, and that is ln absolute value 1 plus e to the x. Well, it's not absolute value, but doesn't matter. So yes, that's correct. Okay, so let's just see what I'm just gonna see what the next ones are. 227, 229. X equals u to the well, some weird ones after this. So anyways, would people want me to do the rest, like the people who are here? Let's see how many people are here. Oh, 2 other people are here. So either of you, would you like me to do the rest of the questions tomorrow or some other time? Or is that good for now? I mean, I have a session on Thursday, but Thursday is for trig substitution and trig integrals. So, either of you interested in more of this, or should I just do the rest by myself? Okay.
What time tomorrow?
I'm not sure. I have a lecture. Well, it would be after 5, for sure. It would be after 5.
I'm a solid maybe.
Okay, sounds good. Yes, that's good. I like that. So, anyways, I'll put it in. If I do it tomorrow, I'll put it in the tutor chat, and it'll be just like I'll be just there doing the rest of the questions, and it'll just be here with just a couple people. But yes, I'll stop recording because that's everything